going to talk about how the Arduino toolchain converts instructions you type into the text editor into machine language the microcontroller can understand. A toolchain is simply a set of software tools that work together to complete a task. So if I were going to hang a picture, for example, the toolchain might include a hammer, maybe a tape measure, and some nails. Let's do this. When programming the Arduino, or anything else, it is possible to write some pretty complex instructions and get the Arduino to do some really cool things. The problem is that a microcontroller, like the ATmega328 on the Uno, can only execute simple, low-level instructions. These simple instructions include things like add variable A to variable B, or take variable B and put it in register X. And to complicate matters, microcontrollers only speak in binary. For those who don't know, binary numbers are long strings of ones and zeros. Maybe we'll talk more about binary numbers another time. So how does a complex statement like this one actually run on a microcontroller that only knows basic arithmetic, logic, moving, and shifting? How do these statements translate into the ones and zeros that the microcontroller can actually understand? Glad you asked. No, really, I am. This is what we're going to answer now. Microcontrollers are electronic devices. So to speak to one, you need to send electronic signals. That's where binary numbers come into play. A 0 represents low or off, usually 0 volts or close to it, while a 1 represents high or on, usually either 5 volts or 3.3 volts depending on the processor. A good way to think of binary numbers and digital signals is like a single pole light switch in your house. The light is either on or it's off. There's nothing in between. A 0 is off and a 1 is on. Going from complex instructions to simple ones the microcontroller understands requires several layers of software that translate the high-level operations into simpler instructions. Enter the compiler. Compiling a program in Arduino is referred to as verifying. The terms mean the same thing, so throughout these tutorials we'll use them interchangeably. Now the compiler first transforms the code you write into assembly language. The name of the compiler we'll be using on our Uno is AVR-GCC. Now if you're new to this may sound kind of weird, but try not to get too hung up on it. It's just a name. The assembler, which is built into the IDE with the compiler, then translates the assembly language program into machine language. It creates object files which combine machine language, data, and information it needs to place instructions properly in memory. Often the assembler creates multiple files which need to be put together. This is where the linker, another part of the compiler software package, shines.